All right. Hello, everyone. So we're going to be doing our last chapter of the organic chemistry portion of this course, and that's focusing on amines and amides. So let's get into it. Both of these are going to be nitrogen-containing functional groups. We'll get to amides here in a few lectures. Amines are the simplest of the two. Anytime that you can spot a nitrogen in your compound and it's bound to carbons, so it's an organic carbon compound, you can classify that as an amine. So the simplest one would be something like CH3NH2, right? That would be methylamine. Um, yeah, notice that it has that nitrogen, which is bound to two hydrogens and a carbon. If I'm going to expand that, let me just kind of make a point here, right? So one of the things about nitrogen is nitrogen likes to have three bonds, and then it also has this lone pair here. But for an amine, any one of those three bonds can be a carbon, right? So for example, this nitrogen is bound to just one other carbon. However, this is also an amine where the nitrogen is bound to two other carbons. This is also an amine where the nitrogen is bound to three other carbons. So any one of those three bonds that nitrogen makes can be a carbon, and that would classify that as an amine. It could also be this benzene ring, which will have its own special name. We'll get to that here in a second, but that would also be considered an amine. Okay. All right. So in terms of nomenclatures for amine, let's just zoom on in. We're going to replace the E with the suffix amine. So actually kind of weird in terms of our functional groups. We don't see this very often. It doesn't have its own little special small suffix that we use. You just put in that word amine. So methanamine would be the name of this compound here, right? If it was two carbons long, so notice we're keeping that same prefix indicating the number of carbons that we've always had. One is meth, two is eth, three is prop, four is bute, et cetera, et cetera. So if we have a two carbon amine, it would be ethanamine. And again, that amine suffix is what we're going to be using to classify our amines. Okay, just like with all of our functional groups, you need to put the location of the amine group as part of the name for anything larger than two carbons, right? So ethanamine, you don't have to put it because it's unambiguous. If we have propanamine, then we have two different types of propanamine. So we have to make sure to specify which one we have. So in this first one here, it's on carbon 1. So that would be 1 propanamine. On the second example here, it's on carbon 2. So that would be 2 propanamine. Okay, and like our other functional groups, we're not going to spend much time being concerned about the common names that you'd see below here. But propylamine, isopropylamine, yeah, so these would be the common names of amines. It means their common names are not as commonly used as some of the other functional groups where we did have to learn them. So let's take a second and see if we can't do this one here. So this is 1, 2, 3, 4 carbons, right? So that would be that bute function, bute term that we would use to indicate 4 carbons. And then the amine group is on carbon 2, so butanamine. And we can, of course, have more complicated structures, these branched structures. So for example, here we have an amine group on carbon 1 and a methyl group on carbon 2. Amines are like alcohols in the sense that you always put them on the lowest number carbon, right? So they have what's called priority in our functional groups, where they're always going to get the lowest possible number. Whoops. So for this case, this would be 3-methyl 1-butanamine. All right, and I guess just to hammer home what I'm trying to say here, let's do another example. Get rid of this. let's go ahead and name this one together here. So first step, as always, is to find that longest continuous set of carbons. That's your parent chain. And then you can number the parent chain both ways, left to right, 1, 2, 3, 4, 5, 6, or right to left, 1, 2, 3, 4, 5, 6. And again, because of this concept of like this priority that amines have, again, they just are like a special functional group. You're going to choose the numbering scheme that puts the lower number on the amine group. We're not even going to look at the methyl group when we make this decision. So in this case, we would go with the blue numbering scheme, and the correct name would be 5-methyl 3-hexanamine. Okay. All right, so that's how you name amines, what we call primary amines. They only have the nitrogen's bound to just one carbon, so they have this sort of like NH2 type functional group. If you have your nitrogen bound to more than one carbon, you have to indicate that using this letter N. So let's just see some examples here. So first of all, you're going to look on either side, right? So look at this on either bond of the nitrogen. So we're going to compare this one and this one. And we have to figure out which one is our parent chain. That's going to be whichever one is longer. So in this case, the green box has 2 carbons, the blue box only has 1. So the green portion will be our parent chain. Okay, so that means that this is going to be a, whoops, I didn't do a good job of that. Kind of just trying to erase just the parent chain portion first, the ethanamine portion. Right, so that covers this is like the parent chain with that amine suffix on that. How do we indicate the other carbon, right? Because again, every time we're doing our IUPAC names, the whole logic is that we've made sure to specify all carbons. So usually we do these sort of where these substituents are based on which number carbon they're bound to. But this isn't bound to a carbon, it's bound to that nitrogen. But very similarly to how we would number them, we're going to include the letter N and then specify that it's a methyl group. And that's how you know that it's bound to the nitrogen. So N-methyl ethanamine. Okay, and again, this N-methyl corresponds to this methyl group that's bound to that nitrogen, right? So much like we identify substituents by the number carbon they're bound to, since it's bound to a nitrogen, we put an N. Okay. All right, so then let's do this other example. So this would be considered, let's just go back for a second. This would be considered a secondary amine because it's bound to 2 carbons. This would now be a tertiary amine because in this example, there are 3 carbons. We're gonna go about it the same way in terms of, first of all, look at these 3 groups. So we have this one, and this one. And we're going to ask ourselves which one is the largest group. That would be the parent chain. So in this case, it's this green one again. So we know if we're sort of building our name here that our longest, because it's 3 carbons, would be a propanamine. That's our parent chain here. Okay. But again, we're going to indicate these other carbons that are bound to their nitrogen, bound to the nitrogen, using the letter N. So this would be NN-dimethyl 1-propanamine. So again, let's just sort of pick this apart, make sure we understand where this came from. My parent chain was this 3 carbons long, so that's prop. The functional group that we have is the amine, so that's why it's propanamine. And because it's bigger than 3 carbons or larger, I had to specify the location of that amine group on that propyl parent chain. Okay. The other 2 groups are both methyl groups. So I'm going to have N for one of them, N for the other one, dimethyl, right? Since they're both methyl groups, it would be dimethyl. Both of them are located on the nitrogen, so it's NN dimethyl 1-propanamine. And then if we have, let's say that there are multiple ones, but they're different groups. So again, the whole logic is you're going to look at each one of these groups that are attached to the nitrogen and determine which one is the parent chain. That one, this one, and now we have that one. Our longest one is the one in green here. So we'll go ahead and number our parent chain, 1, 2, 3, 4, 5. We see that the nitrogen is bound to that second carbon. So this should be a pentanamine, 2-pentanamine, right? Because again, that nitrogen is on carbon 2. So now we have 2 substituents on the nitrogen. So again, we'll indicate that with the letter N. One of them is a methyl group, right? So in pink here, in purple here, we have this methyl group. This is going to be an N-methyl group, and then we have an N-ethyl group. And like always, when we have multiple substituents, when we go to build the name, we're going to make sure to put them in alphabetical order. So this would be N-ethyl, N-methyl, 2-pentanamine. All right. It seems like there's a lot going on with these N's and everything like that. Once you get to practicing, you'll realize it's really not too bad. I think it looks a little bit more intimidating than it is. Okay, so let's go about naming this one from scratch here. So again, we're going to look on this is a secondary amine, so we're going to have to decide which portion is the parent chain. We have this chunk here, and we have this chunk here. The one in purple is obviously the longer of the two. It's 4 carbons. So now we need to go ahead and number our parent chain, give that nitrogen the lowest possible number, and then name our substituent. This is now an N-methyl group. So we have N-methyl 1-butanamine. Okay, so now when it comes to our aromatic amine, we always have like a special name for those, right? Like our aromatic alcohol was phenol, our aromatic aldehyde was benzaldehyde. The aromatic amine is aniline. I don't actually know where that name comes from, but and just like with our other ones, if you have an aromatic ring with a nitrogen and another group, you consider that to be the parent chain, right? So this would be 4-bromoaniline. That's now our new parent chain. And if it's a secondary or a tertiary aromatic amine, you indicate what group, how many carbons is attached to that nitrogen in the same way we were just doing. So this would be, again, we have this amine functional group on our aromatic, so that's an aniline. And then we have this additional carbon on that nitrogen. So this would be N-methyl aniline. Anilines can be very colorful. They can, so a lot of dyes contain aniline functional groups. All right, so again, I kind of already said this because it made it easier for me to discuss the previous concept, but now let's just hammer this home. We have primary, secondary, and tertiary amines. And the difference is the number of carbons that are bound to that nitrogen, right? Notice that this is a little bit different than when we were talking about alcohols. That oxygen could only ever be bound to 1 carbon, right? So this would have been a secondary alcohol because you looked at the carbon that was attached to the oxygen and counted how many carbon neighbors it has. For amines, it's actually a little bit more straightforward. You're looking at the nitrogen and just counting how many carbons are bound to that nitrogen. So for, there's 1 carbon bound to the nitrogen in this one, so it's a primary amine. If it has 2 carbons bound to the nitrogen, it's a secondary amine. If it has 1, 2, 3 carbons bound to the nitrogen, it's a tertiary amine. Okay, so we have the same primary, secondary, tertiary designation as we've seen before. Because nitrogen can have multiple bonding partners, it's a little bit different of a definition than before. All right, so classify the following as primary, secondary, or tertiary. Again, you're just going to count how many nitrogen or how many carbons are bound to the nitrogen. So in this case, we have a primary amine, and in this case, 1, 2, 3 carbons are bound to that nitrogen. So this would be a tertiary amine. All right, and now the IUPAC name for these amines here. Again, we got to block off everything that's attached to the nitrogen to figure out what the parent chain is. So that's one chunk there, one chunk there, and one chunk there. Okay. So in this case, clearly, this methyl group isn't going to win. This will be an N-methyl. The other two are tied, so you could just pick whichever one you want to be the parent chain. It doesn't really matter. The other one will become, in this case, an N-ethyl. And because we only have 2 carbons, I actually don't have to specify the position. I know off the bat that the parent chain is an F-anamine. And then again, I'm going to put these other substituents in alphabetical order. So this would be N-ethyl, N-methyl, F-anamine. For this compound here, I have this aromatic amine. So this is my parent chain, this aniline. Right, but I'm going to have to specify this chunk of carbons right here bound to that nitrogen as N-ethyl aniline. Sort of close that space so there's no space between those, right? Run them all together. And then, of course, I've sort of forced you guys to be good about working with these bond line structures throughout the semester so that you guys will be pretty good. I will say, primary, secondary, tertiary, you can see that all primary amines have an NH2, right? So there's 2 hydrogens on that nitrogen. All secondary amines have just 1 hydrogen, and tertiary amines don't have any hydrogens bound to them. So they're just like sticks coming off. You do explicitly write the hydrogens that are bound to the nitrogen, okay? Another thing you might see for like a secondary amine would just be something like NH. Maybe that bond isn't written in that stick form like it is here. But nonetheless, all amines, if there is a hydrogen bound to the nitrogen, you would explicitly write it. You see that there aren't any with the tertiary amine because there's 1, 2, 3 carbons that are bound to that nitrogen.